Welcome to the Demystifying Technology podcast from the MacLaurin Group.
Typically, you go through the due diligence process. What the world of private equity?
Right. Can't wait. Demystify it.
You might have heard the term CICD getting kicked around. Ryan and Alan delve deeper into what that means and break down the complexity of software development.
Welcome back. Our public has demanded that we educate more in the world of continuous integration, continuous development, buzzwords that we'll dive into later on. So we've got Ryan back here again. We had a successful version control intro there where we looked at really the benefits of what version control can do for a team and a development and an organization. But there's an evolution. You can do much more with that. So, Ryan, it was a great stepping stone in our last podcast. So what can we do now? We've got all this source code sitting in our version control repository. Mm-hmm. What now?
So the next bit is getting into release cycles, right? So now that you have your code in the central repository, you want to actually release it out to your servers. So what you want to be able to do is start to build it in a more controlled manner where it's not getting compiled or whatever steps need to be done on the developer's local machine. Instead, again, on some other central server, some central process, the release is being done from there. So that way, again, it's reproducible. So that way, every time you're going to production, you have a nice clean, okay, here's the revision that I want to push out. This is the particular version of the code I want to push out. And then you build it and push it from there. So it goes out to production.
And we know this is horrendously important. Why? Because everything works on a developer's machine.
Yes. It always works on my machine.
Always works on my machine. So when we're talking about release, we're talking about finding that reproducible set of steps to get us to a known state that's outside of the developer's machine. So there's no dependencies, no files, no configurations, no special scripts. Oh, you didn't run this before that.
Exactly, yeah.
It's getting that clean break. Now, version control, in our last podcast, we talked about various branching and what have you, but there's more of a philosophy associated with this world here. So we've got things like centralized, feature branch, git flow. So let's talk about just a little bit of the high-level differences between these sort of fundamental ways of managing your version.
Right. So when you start talking about Git especially, there tends to be different workflows or philosophies in terms of how you lay out your branches or your code inside of it. So the most simple one that people use would be what's called centralized workflow. And with a centralized workflow, you can think of that as SVN. You have a single timeline, as it were. Mm-hmm. So everybody's working on that timeline, and that's it. It's very nice and easy. Taking it to the next step, that's where you would introduce the feature branch workflow. And with the feature branch, you still have that main timeline, but every time somebody's developing a new feature or making a change, they would create their own timeline, do the development on that, and then merge it back to the central one. So you just kind of have people pulling off, and every time they're doing a feature, they're creating a new branch. The last one, which starts bringing a little bit more complexity, would be git flow. Git flow, you have kind of two main timelines. You have one that's the main timeline for production, and then another timeline that's kind of for your dev or staging environment. Most of the development's being done on that dev or staging environment. People will be creating feature branches off of that, merging it back. And you also have the concept of hotfixes. So hotfixes, if, say, for example, you have something out in production off the release branch, and you need to do an update, you create a hotfix branch. So it's just creating more branches off of it. From there, there's obviously, every shop kind of has their own variation that they do. Well, I'd say that's kind of the three main categories. In terms of how you do your branching, your features, all that sort of stuff, there's a wide variety, and that's how they mix it up. But that tends to be the main ones.
So what problem are we trying to solve here by leveraging these sort of design patterns for managing our version control?
So it's mainly just trying to get a set of rules in terms of how the code is being managed for a release, right? So if we go to just the simple one for a feature branch, right, it's a little bit more complex than the centralized one. But what that allows you to do is you merge a feature back to the master branch when it's ready to be released to production, right? So it allows developers to go off, do development independently without having to worry about it making it to production accidentally. It only gets merged into the branch that's ready to go production when it's time for it to be merged. So it allows it to be done independently, but when it's time to release, then it gets merged.
So it basically gives you a process to which to have a clean line in the sand that this is now ready to go, and everything we're going to do, line in the sand, is now destined for the release side of the fence, but it frees up the development team to continue on with their development without holding back until somebody said, yep, production is green, you can now start developing again.
Yeah, and it's just one of those cases, that's why I think very few shops are probably doing this sort of version control system or workflow the same. Everybody has their own variances on it, and that's just because, again, it's how does your team work? What fits their team to be able to manage that code and manage releases so that you know what's going to production and you know what features and stuff are waiting to go production. It's just kind of managing that.
Okay, so let's dive in a little bit deeper. So the developer has now cut their code, they've checked it in, and as far as they're concerned, they're finished with it. There's a whole life cycle that can be now done with that source from here on in, and this is part of the CI part of the equation. So talk a little bit about what can be done now.
So generally, after you've finished cutting code and making changes, there's a series of steps that need to be done. If you're dealing with a compiled language such as Java, for example, you need to compile your code into some form of binary that is going to be pushed out for testing. Testing, automated testing, if you have unit tests, those need to be ran. There's just a number of different formatting that could be done. So this is where you get into some of the linters. That's kind of checking to make sure, okay, are you following the guidelines that we've outlined for how code should be written, or have you kind of deviated? Same sort of thing, Sonar Cube and some of the other automated testing go in to say, okay, is there potentially bugs in this? Have you left a resource open and that sort of stuff that maybe unit testing didn't pick up on? So there's this whole suite of tools and utilities out there that can be done on code to improve the overall quality of the code that's being generated.
Okay, so we have effectively code that goes in 2 cycles. Well, there's 3 cycles. There's the actual development design part of it. Then there's the part you just discussed, which is the cleaning up, the testing, all the usual quality side of the fence, and building as part of that. And then we get to effectively the deployment stage, and that's getting the rubber to meet the road to get out into either a staging environment or a production environment. Now, we have, because we're an industry of acronyms, I mean, if we can say a word, what's the point? Let's use some letters. And this is where we start to hear the word CICD kicked around and tossed around. So tell us the difference roughly, Ryan. What do those 2 horrendously sounding common phrases sound like?
Yeah. When you see CICD written out, it's actually CI/CD because it's symbolizing that it's 2 different steps of kind of like a pipeline or a process. So the first bit is CI, and that's called continuous integration. So that's basically where you're doing all the steps that I previously outlined, where you're building your code, you're testing your code, you're running any analysis on it. It's getting the whole concept there is you're integrating your code back into the main workflow. So you've gone off major changes. Let me run the automated suites and make sure that, okay, my code is ready to be merged in with everybody else's. So that's CI. Now, the CD side of the fence is really kind of can stand for one of 2 things. It can stand for continuous delivery or continuous deployment. Now, both of these is the concept of you are automating, to a certain extent, pushing the code out to production, pushing the code out to development. It's that actual taking the code after it's been built and checked out and pushing it to a server somewhere where other people can interact with it, whether that be your testing team or production. The distinction here is when you're doing continuous delivery, somebody is doing that final manual push to production. And when I say manual here, somebody's coming in and saying, okay, this is now ready. I'm approving this to be pushed out to production.
So there's still, while we've got the word continuous in these things, usually at the last moment there is a human that does.
Yes, if you're doing continuous delivery. Now, if you're a more advanced shop where you're kind of doing what I would say the purest version of CI/CD, at that point the whole thing is automated. So literally from start to finish, once a developer checks in a code, test suites run, as long as all the tests look great, his code quality is great, it'll push out to development. After a certain amount of time, it'll then push to staging, more testing is done, and then it'll automatically push out to production. So that's continuous deployment, whereas continuous delivery is just you're pulling that back just a little bit, and you still want to have a person to say, okay, no, this is now ready to go to production. They click a button, and then it kicks off the rest of the pipeline.
A good subtle definition between the 2. So we've talked about these events, etc. So what kickstarts this process, Ryan? What is the first domino in the chain?
So it's almost all pipelines, the first domino is going to be a check-in, right?
So the actual commit to a given release branch or a dev branch or whatever.
Whatever it may be. And then, like I said, that just comes back to what workflow you're using. But fundamentally, the developer has checked something in, and then there are hooks in place that say, okay, I see that developer just checked in. I'm going to kick off generally the CI part of the pipeline at the very least. So that's where tools such as Jenkins, AWS Code Pipeline, some of those sort of things, they'll kick in and say, okay, yep, you committed, run this test suite. And then after you've run that test suite, okay, run the code linters and all that sort of stuff to make sure the code looks good, and it just goes from there. So it's generally a commit. Once you've committed, that's the kickoff point.
Now, you can fail in this process.
Yes.
So it's important that whatever tool or tools that you're running against your code can actually in fact report an error to say, hey, this ain't working anymore. We're not going to let it go further up the pipeline because the pipeline suggests sequential, one after another.
Yeah, so I mean, you can get advanced with this to a certain extent. So at its most simplest form, at that point, your pipeline would fail. So it's not going to keep going. So once it kind of hits, for example, say you had a compilation stage, compiled fine, but then when it started running the unit test, it failed. At that point, the pipeline stops. The pipeline doesn't keep on going. You could have the pipeline keep on going, but that's kind of danger. Why would you keep going? Generally, at that point, the pipeline can fail at any stage. You also have alerts baked in, so emails will go out, Slack notifications, whatever, to the development team to say, hey, this check-in that was just kicked off, it has these problems.
That's what we call the humiliation stage.
Yes, exactly, right? Like nobody wants, so that helps enforce the team to do more testing locally, because if you're getting to the point that you're checking it, it's kind of instilling that fact that, okay, I'm committing this, I know the suite of things are going to be ran against it, so, and if I fail, I'm going to get called out on it by the system, because there is that sense of accountability.
And most of the time, in all fairness, it isn't necessarily tests failing. Yes, that's a large part of it, but historically, when we've worked in teams together, it's usually been when a developer has forgotten to check in a file or forgotten to check in a dependency, and because of that clean world environment of where, hey, I have no historical notion of what this project is, I have to bring in all my assets, I'm doing a clean build, oops, I've missed a jar file, or oops, I've missed an NPN module.
Most time it is as simple as that, yes.
So that sounds awfully complicated and something the big boys are doing, but we know that most of the shops that we deal with are small, leaner. Is this complicated?
I would say it's a little complicated to first step into it. It's one of those things when you first look at it, it looks like a big mammoth staring you down, but you can bite it off in chunks. You don't have to go the full bore. Like I said, I've seen very few shops that can do the full CI/CD pipeline where literally check in, run test, do the push to stage, test, and on out to production, whatever it may be. Because all you got to do is hook on, I'd say at its simplest form, it's that first hook. So once somebody's made a commit, it could be as simple as running a shell script, right? So there's a commit, your central repository generally is a server, so it detects that commit, and there's a shell script that runs that maybe compiles the code or just runs some unit tests, does that sort of stuff. You can then start bringing in more complex bits, and it's adding on to the pipeline. It's the beauty of this pipeline is whenever you actually start seeing these things visualized, it's literally kind of like blocks in a
flow diagram.
Yeah, it's a flow diagram where it's these blocks. So as you get more familiar with it, you're just kind of bringing more blocks into this pipeline and building it up over time. So it's just a case of, okay, you start with the CID of, I just want to be able to compile this on a remote machine. I'm not even going to worry about running tests. I just want to compile it somewhere. Then you start saying, okay, I want to run tests. And it's just building it up over time. And
it can be as simple as just running a series of shell scripts or commands, whether it's Maven, Ant, NPN, whatever that tool of choice for your language is.
And in those cases, the shell script's going to be running the commands that the developer himself is running via command line on his machine. So if the developer is using Ant, for example, he's probably running an Ant package or a Maven package or some command on his command line when he does his testing. It's just now you're hooking a shell script onto, as soon as somebody commits, it runs that same command that he's typing into the command line. It is doing it on another server.
I would say that having gone through this many times myself, one of the steps that usually trips up new people in this world is you have to set up your environment beforehand. So as part of that pipeline setup, one has to make sure you've got the right version of Java installed or the right version of NPN installed. Basically all the stuff that you as a developer have probably forgotten you've done on your development machine. And it's kind of that sort of stuff when a new developer comes into the organization, you realize, holy crap, there is much more set up here than I thought. But by going into this process, you sort of eliminate that, and in many respects, speed up the onboarding process for new developers coming in because it's a much more reproducible environment. But the key here, of course, is the automation. And that's where you don't get into, I've forgotten to do a step. Oh, we didn't do it for that, Bill, don't worry about it.
It's the continuous bit. The fact that everything is automated and hooked into these events, like I said, in most cases, as soon as somebody checks in, it kicks off. It isn't waiting on somebody to come in and push a button and say, oh, well, let me run that test now. No, it's as soon as they commit, it's kicking off on the back end and running. And in most cases, it's going to be behind the scenes, especially, for example, if you're just doing the CI part, where you just want to do this stuff. Most developers, they're going to kick it off, test, everything runs fine. So it's just running behind the background to say, oh, yep, everything's still green. Everything looks good. But when something inadvertently gets checked in or a bug gets introduced, because kind of back to what we talked about before, when you make these sort of changes, they can have knock-on effects that you didn't anticipate. So I'm changing this feature A, and then it impacts feature B. No idea that they interacted, and that's where your unit testing kicks in. So with the continuous bit, it would start running, and then 5 minutes later, whatever it may be, that's when they would get the alert to say, oh, this failed, and that developer can quickly say, oh, yep, nope, I see what I did wrong here, and they can immediately take action to fix it, as opposed to it being a week later that somebody's finally getting around to run this thing, and it's like, well, now we have this pile of issues. No, it keeps the issues nice and small and helps keep the nice code nice and clean.
So we think about the release process, we think about our source code and our version control system. Up till now, we've talked about it holding only our raw source files. Mm-hmm. But there's more that can go into this world now.
Yeah. So, I mean, you can basically start baking in the likes of, for example, if you're using Docker, you can use it to build your Docker containers. So most places, if you're using Docker, there's this concept of kind of a base image, or you can be the whole deployment image. And so, again, you want those to be built in a nice standard fashion. And a lot of times you want them to be kind of automated because, for example, with Docker, you want to make sure that the image is getting updated every so often. So that way things like OS upgrades, that sort of stuff gets done, which is for security patches. Anything that's inside of your infrastructure that kind of has this concept of there's a person hopping on a box to go run this task every periodically, all this sort of stuff lends itself well to the concept of automation. So once you start stepping into this with your code, what you'll start finding is there's a whole lot of other things around your ecosystem that could lend itself to this automation. And having just the fact of, sure, you're still always going to have that person, the DevOps engineer that needs to come along and make sure things are running correctly and not getting stuck, but it makes their lives a lot simpler. They're not spending time hopping around boxes. They can be putting their efforts to something more valuable to the company as opposed to these kind of menial tasks that are just routine.
And they too should be using version control for their scripts and setups and configurations.
That would be what's called infrastructure as code, which I'm sure we'll probably do in another podcast. But yeah, as much versioning as you can do for that, again, that just gets you the history of what are they changing, what did our infrastructure used to look like. It's extremely valuable. So
we've talked about CI, etc., and let's move on to the other side of the slash. When we talk about the release process, okay, this is the fundamental stage of getting that code out into the hands of your users, whether it's testers, users in a staging environment, or the actual end user. What are the red flags that we're looking for here that suggest that you may not be as slick as you could be?
If there is somebody having to SSH onto a box to perform a deployment step, that to me is generally a red flag, especially when we start going into companies to help them out.
Now, why is that?
To me, it's one of those things because the beauty of automation is it's reproducible, right? It's done the exact same way every time. If somebody's having to manually get on a box and do this deployment, it's that concept of human error. You just get certain developer fatigue, you get release fatigue, whatever it may be. Inevitably, somebody forgets a step. And so then even then, if you forget a step, you don't have, in most cases, you don't even really have the steps that they did execute. So it can be troublesome to figure out exactly what they did and how you got to this state. Whereas if you have a pipeline that's doing this and it's automated and it's a server, generally all that's getting logged as it's executing. So you could kind of see exactly what steps it took. And you see exactly where it failed in those steps if it does encounter an issue. Right? And then at that point, it's 100% reproducible. You can generally do the bit that you did to release to your staging environment, you can then do to your production environment. So you get to reproduce it and keep flowing and seeing exactly what was done.
And in many respects, the release to production should be a non-event because everything that happened in staging will have been fleshed out at that point. Yeah.
And so, if you have somebody that's SSHing or FTPing files up to the server, inevitably it's a case of, well, maybe they didn't have to copy a file into staging because it was already there, but it's not on the production box, right? Because it was done at a different point in time. With automation and with these tools, that should kind of go away, especially if you start using the likes of Docker and some of the other bits coming in where you can really ensure a nice, clean environment.
And we've also got the, when we're talking about SSH, it's username and passwords. And if Bob is off for the week, does that mean we can no longer release code? Because Bob's the only SSH key we've got on that one box, or if that one box dies, etc. Okay, so there are a number of ways we can actually physically release code. So we've got the traditional, I have a data center and I've got physical servers, whether in blades or sitting in a virtual environment, but you control the hardware, to more of the sort of true cloud-enabled environments. So let's go through some of those different types of deployments.
Sure. So I think they generally fall into two categories, as you were kind of alluding to. When you're in the cloud, there's the concept of in-place updates. So you've already created a server, whatever it may be, and you're going to go out and push the changes to it.
So let's pretend we've got an EC2 instance, just say we're in AWS remote. That server's been stood up.
Yeah, it's been there for months, and you're just going to basically push your code out to it, so it's now running the latest code. At that point, that's going to be generally some form of either Docker container again, or maybe Jenkins itself is executing a shell script to go in and run a certain sequence of steps to update it, but it's doing an in-place upgrade. However, that's generally where most people start, I would say, because that's very data center.
Traditional.
Yeah, it makes a lot of sense. It's very easy. The beauty of it is when you move to the cloud, you can start treating servers as temporary citizens to a certain degree. You can create and destroy them on the fly once you get your process figured out. And so one of the very popular mechanisms at the moment to help with some of this releasing is called blue-green deployment. The concept of blue-green deployment is you have your blue environment, which is your existing servers that's running your old code, and then you effectively clone it. So you bring on brand new servers that look like the blue one, and that's going to become your green environment. And then what you do is your pipeline pushes your new changes out to the green environment. So changes are only going to the new one. And that allows you a lot of times, again, depending on how far you take this, you can even start testing on the green in isolation, so you can kind of make sure that your changes are working, everything looks correct.
So this is like a way to let users into, or usually your own testers.
Your own testers, right, yeah. And it just allows them to get in there and just play in the green environment. So they're in production, and they're generally still playing with the production database, but they get to play with the new code in production before it gets to go to your actual customers. And then after a certain period of time, what they'll do is they'll basically swap them. So then while the blue environment has been active all this time on your customers, now the green one's going to become inactive. So your customer traffic will start going to that, and then you'll monitor it, make sure everything looks well. And if all is being well, you basically tear down and destroy the blue environment, and just the green one lives on. However, let's say something goes wrong. The beauty of the blue-green model is, say you cut over and something didn't get caught in testing, but all of a sudden your customers start reporting, oh, there's this issue. Well, you can very quickly revert back. You just basically re-promote the blue environment back to the active environment, and your customers go back to being happy. And then you can tear down the green, go back to the team and say, okay, what went wrong? Let's figure this out, and then we'll do another blue-green deployment tomorrow, or whatever it may be, to get it out.
And it truly is like an edit on do in the cloud in that respect.
Yes.
And because the cloud is not physical servers to which we buy and manage, we can easily do this game. So effectively, yes, we're doubling up our cloud bill for that short period of time in the blue, green, but that's nothing in the overall concept of this ability of instant rollback.
Yep.
Because sometimes we've seen ourselves, they just can't roll back.
Yeah, and that's when you're talking about the in-place upgrades, that's where you get into a little bit of danger, right? Because it could be a case of it's very easy for a shell script to push out changes and get all these files to a certain state, but then when you have to say, oh, well, let me completely unwind, well, now you have files that maybe you added and you got to make sure they get deleted. Whereas with this kind of blue-green and in creation, it's exactly the way it was. I haven't made any changes to it.
Or the dreaded, you've run out of disk space.
Oh my, yeah.
I mean, it's game over at that point. Okay, so what is the good aspects of a good deployment strategy?
So with a good deployment strategy, I would say at the top of it would be security. So not just anybody can generally release code out to production. Hopefully, if you have a brand new intern, you don't want him to be the one pushing code out to your production environment. You generally want that to be somebody more seasoned to know what's going on. So with these automation tools, almost all of them have security baked into them in terms of who can do what. And you can control who can see these different pipelines and execute different steps. So you have that control over who's pushing code out. Again, because there's not this manual changing of things, you have that accountability of who changed what and where in the pipeline where things changed. So you don't have that concern of, oh, well, we didn't push this file from the staging server, so therefore it didn't work. You get rid of those sort of problems. You have this nice clean audit trail of what's been changed and in making sure it all gets pushed out correctly.
Yeah, and the important thing to note there is it's not that we're looking for the fall guy as to why this broke. It's generally figuring out, okay, which feature actually brought it down? What did we probably not think through completely that has now caused a lot of unintended consequences that we now need to rethink about?
Yeah, 100%. So one of the terms you've probably heard quite frequently, especially with a lot of these big tech companies, whenever something goes wrong, is they're going to do a postmortem, right? And so that postmortem is them going back and looking at these change of events to see, okay, what led us to encounter this issue? It's not necessarily to say, oh, well, we got to go fire Bob because Bob messed us up. Very rarely is it because of malicious intent that something's been done. It's just there was a skip step or whatever it may be. So when you do the audits, it allows you to go back and say, okay, where do we need to refine our pipeline? Where do we need to add in more checks? Where do we need to put more? So again, it's going back to that. You have many boxes in your pipeline, and over time as you identify, oh, this went wrong, generally you're going to add another box into your pipeline to ensure that doesn't happen again. Or you're going to modify the box to make sure, okay, we're going to take into account what went wrong and make sure it doesn't happen again.
And these extra steps are not extra burdens on the developer.
No.
This is what's beautiful about this process. It's not like you're asking Bob to now, okay, here's yet another thing you must do before you check in your code.
Exactly. Kind of going back to that whole, if a developer is the one doing this and managing this is another thing that he can potentially forget. Again, when you're automating it into a pipeline, the pipeline doesn't forget.
So what are we looking for here? What's our litmus test or our gold standard we're striving for?
The main thing, kind of, especially when you look at the blue-green deployment, is that ability to confidently roll back a production release. I can't begin to tell you how many shops we've seen where once something has gone to production, if something goes wrong,
they have to fix the production release.
They have to fix that now. There isn't this concept of it needs to work now because we can't roll back. And having been out of that world, thankfully, for a little bit, whenever I see it again, it's kind of one of those, whew, I don't miss this. We always called them fire drills where I used to work, and that's not a good day. However, when you have this automation properly set up and you have everything properly configured, that should just no longer be a concern. I'm not going to say it completely eliminates it, because there are always certain things. For example, generally, even with blue-green deployment, if you're making changes to the database and you don't do them properly, that can still cause an outage, but it shouldn't be necessarily code changes. It gets you that reliable ability to say, okay, push it out. Is everything going well? Great. If not, we're rolling back to what we had there previously, and we know exactly that it is what it was previously. There's no question around that.
Yes. So we've covered a lot here. We're probably, maybe have overwhelmed our smaller shops, etc. But how do they get started? This is a huge landscape we've just described.
To get started with the CI side of the fence, I would say you're doing the remote building, at least, of your execution libraries. If you got compiling, don't have the developer be compiling on his machine. Let it be compiled on a remote server. Obviously, if you have test cases, awesome, run them. If you don't, that's okay. But again, it's just building whatever you're going to be pushing out and off of a developer's machine. It's on a central server. It's not on the developer's machine. So that way you can do it reliably. And the next bit after that is just going to be starting to try and reduce how much you're having to SSH onto a server to push that code out. So just very simplistic CI side in terms of building, and again, start with very simplistic deployment. Start being able to script out what that developer's doing to push out code, so that way now this automation pipeline is the one pushing it out. And honestly, it's probably going to be one of those cases of maybe the first time you do it, that pipeline only takes a couple of those steps away from the developer. Like, build up your confidence if that's what it takes, but just slowly sink yourself into it and start pulling more of those steps that can be automated out into a pipeline.
Yeah, and I would say that your anal retentiveness, Ryan, while it frustrates the hell out of me at times, you do go through that process of when you're standing up boxes either for ourselves or for our customers, you will tear it all down again because you want to test everything again to make sure that you got that thing back up to an own state.
Yes.
And everything that you have got checked into your DevOps folder. You've got a signature, my friend.
Yes.
That is indeed reproducible. It's not a case of, right, it stood up, next project. You generally tear down and go again. And I think that is a step that most people often don't do because they see it as, I've got it going now. I've got this to-do list that needs to be done. I'm getting shouted at to get progress done. Why do I have to go through this process? But you've demonstrated that it's a really well worth test. As long as you've got that framework, you can keep adding into it.
Yes. It's basically the concept. So most places honestly have a database. So it's kind of that concept of, okay, I'm taking database backups, but have you ever restored off of a database backup? Because you don't want to be in that 12th hour, things are going wrong, your database has crashed, and this is the first time you're trying to restore your data from a database, because probably it's not going to go well, at least not as well as you expected. So taking kind of that concept and applying it to your infrastructure and how you deploy code and being able to say, we can reliably recreate this, saves you so much hassle down the road that the time investment is usually well worth it.
So, talking investment, that brings us on to our last sort of area here. Is this expensive?
No, it can be extremely cheap, especially, so again, for AWS, because obviously we really like AWS. The likes of AWS code commit for your Git repo, we talked about previously, you get first 5 users free, and then it's only $1 per user after that, so that's really affordable. To kind of get you your pipeline set, they have something called AWS Code Pipeline. They're real original with their names. And again, it's $1 a month per pipeline. Doesn't matter how many steps are in that pipeline, just $1. And then for the actual execution of those steps, they have the likes of code build, code deploy, which is kind of, you get a server on demand to execute, and that charges you per minute of how long it's executed.
Yeah, and that's worth pulling out there, because you're not having to run up yet another server in your infrastructure. They will
it's basically Lambda for building code.
Yeah, they will throw up a machine on demand, you execute all your scripts, and for the Java people, etc., think of it like running up a server to run a whole bunch of Ant scripts, and then whatever that Ant script does is up to you. They're just giving you CPU.
And so if your build takes 5 minutes, I think it works out to like it's half a cent per minute of build time. So like that 5-minute build is going to cost you 2 cents. So it's not like you're generally running 24/7. Taking it to the next step, if you want to start getting more advanced, that's where you're going to start using tools like Jenkins, SonarQube, all that sort of stuff. And those generally will be either a server you're running in-house, so you're going to be paying whatever the server costs are. Generally, I would say most of those servers are going to run you about $30-$40 a month, if that. Or you're going to be going to more of a SaaS offering in the cloud. Because I know like CloudBees and GitHub, all of them have their own cloud. And then those can start getting a little bit more expensive. So there really is a wide range here. And it just comes down to, are you stepping into this? Then you probably don't need a whole lot of features, so you can get really cheap. But as your team progresses and you start doing more with it, you may want to be spending a little bit more money to get some of those features.
But you'll know at that point. So that's more. So the first phase is truly a revolutionary point to get you into this world to begin with, and it can be very cheap. Then after that, it evolves into an evolutionary stage. So if you're getting to the stage of you're writing relatively big checks at the end of every month for your CICD, you know why you're doing that.
Yes.
There's a reason why you're...
And I would say 90% of shops, if not more, are not going to need that big, expensive checks. Like most of those big features, I mean, you got to be starting to get into a pretty big size development team / company to be able to justify, I'm managing hundreds of developers or thousands of developers. So that's when a lot of those sort of features start kicking in. Most shops that we're dealing with, the very simple, like if you're generally, I'd say if you're spending probably more than $50 a month on your between your Git repo and your build server, whatever it may be, you're probably starting to spend more than you need. It really should be relatively affordable and cheap.
Brilliant. Well, Ryan, thank you very much. This has been good. Again, if anybody's want to start out in this, feel free to reach out to us. We're happy to talk. But this was a good insight into both version control and CI/CD, and stay tuned for more exciting topics coming in the future.
Looking forward to it.